All right. Yeah, so I'm going to start with just what we built. As you guys know, we built a game called TFTanks based on using the TFT display and remaking just the classic tanks game that a lot of us have played on cool math games and addicting games and a lot of other games from like elementary school time.
And so for this project, kind of similar to other game projects this semester, we only use the PIC and the TFT display, which means we just have an SPI channel connecting the two of them. And we also just have serial interface with the Python. And we actually do that going backwards as well, which we'll get into in a bit later.
Yeah, so just what we're seeing on screen right now is the Python display. So we have sliders for both the angle that you're shooting, the firepower of your shot, steps to move left and right to actually fire. And then these variables that we have in red, orange get updated. So that's how we send from the PIC back to the serial, over serial back to Python, encoding like what's the new value of these variables to be displayed when something happens. So for example, I'm going to take a step right and my steps remaining is now 4 because you only get 5 steps per turn. And it's player 1's turn, and these are our 2 healths as well. So just going a little bit into the software, the main 3 things that are always running are the buttons thread, the slider thread, and the animate thread. So the buttons and slider threads, they are taking in the serial input from the Python and reacting to the user action. So the slider thread would get a new value, a flag is set every time it moves on the Python interface. And then that angle is sent to some methods we have to draw the cannon at that new angle. So that's how it takes in this event. But the main thing we have running is the animate thread. So that runs every 30 milliseconds.
33 milliseconds.
Every 33 milliseconds, corresponding to a 30 FPS frame rate. So it's firing every 33 milliseconds. However, it's not doing anything when we haven't taken a shot yet. So as soon as we press fire, then we start doing incremental velocity calculations, just projectile motion. So updating the shell, we call it, which is our projectile, Vx and Vy by incremental steps every time. So for example, the shell Vy is updated by gravity every time. And then also the positions are updated. So every 30 FPS. And then we also have, let me try to hit them.
This is how good we've become at the game. If we practiced our own game a lot.
Yeah, we'll see if I can hit them.
So I'm noticing too that as you're taking these shots, I'm seeing in the interface, it's indicating the other player's turn and the steps remaining also is resetting.
Yeah.
Right. And then if we hit them, their health would decrease, etc.
Right.
The power slider can be a bit intense. You can fire very quickly, and unless you're going basically straight away, you'll be way off the board. We basically, one thing we do we'll get to later is when we talk about terrain destruction. The power slider actually makes it variable. There we go.
Okay, there we go. We had an explosion animation, so that goes back to the animate thread. So it's running every 33 milliseconds, but then it has different cases based off what is happening. So if fire equals 1, that flag, it means we're in the middle of animating the projectile. Then as soon as you hit the hitbox, we have like a hitbox to detect collision around the tank itself, which is just like a range of rectangle of pixel away from the rectangle, from the tank center. That sets a flag to then start the explosion animation, which just draws increasing concentric circles. I'll do it again. And then, oh, sorry, go ahead.
And I see that your player health is now dropped to 2.
Yep, and now it just dropped back to 1, and then that is updated. Yeah, and I'll just finish the game because I have the shot lined up.
And I guess I'll go into the team structure briefly.
Yeah.
Yeah, so we store the tanks. As you can see, they're kind of a triangle. Once the game ends, we can make a new game.
Yeah, so then this is, it's sitting on a game over screen again in the animate thread. So there's a new flag that either of the players' health have gone to 0, and it displays who won. And it sits here until and waits for yields until a button press that sets a flag with new game. and we get a new random map, which Morgan will talk about later. But
Yeah, so briefly, so the tank itself is a triangle, and we have a cannon that is another kind of rectangle attached to it, 1 pixel wide. And the projectile is stored at the tip of the cannon and moves kind of with the cannon. So that's kind of its initial position where it starts. And things like we store kind of the angle, where we are. We do base positioning based on the middle bottom of the tank. You'll notice when it's in the land, it's always kind of with regards to the middle point. That's kind of how it moves around. Yeah.
Yeah, we explored turning the tank, but we actually thought it would look more silly if he was like going up a mountain at this angle. So we liked kind of like the arcade feel of it, just moving up and down
Sure.
as it went.
Map stuff.
Yeah.
All right. Yeah. So another focus of mine was like the land generation and storage. So the way we handle that is the TFT width is 320 pixels. So we have an array of length 320 storing integers. And each index in the array corresponds to the X position of the land, and each value stores the land height. So for example, like, I don't know, say this is like 50, this might be like 100 or something like that. So we store that at all times, and we can redraw it as necessary. Like if an explosion happens, we redraw the land at that point by looping through the relevant section of land, et cetera. And then to generate these maps are all completely random, which is good because that reduces storage. We don't have to like store different maps or something. And the way that works is you start at X position 0 and you choose a random height. So you can see how this went. And then you increment X by, we chose 30. That could be a variable, but we found 30 looked pretty good in general. So yeah, so you increment X by 30, and then you generate a random number between 0 and 1 and multiply it by, originally we multiplied it by the TFT height, but that would cause these mountains to go all the way to the top of the screen, which while we could do that, we thought that was a little unplayable. So this is like, the maximum value is roughly like 80% of the TFT height. And then once you compute this new random point here, then we compute the line segment equation and fill the array with the values along that line segment. And then there's a function called like, I think TFT V line. So you draw a vertical line at every point in the whole array. And that's how we randomly generate this land.
So yeah, I guess you'll notice that like the peaks are all evenly spaced, even though it looks like they're random because we are making a new random value at specific intervals, but the value itself was actually changing.
Gotcha.
I'm gonna reset it. So this display screen is another thing happening in the Animate Thread. When you first start the game, it's just yielding until a flag is set by the start button. And because the user will press start at a random variable amount of time after the start of the game, then this seeds the random number generator. So that's how you get different maps between times you play. And then obviously, after you seed it once, we don't seed it again. We just redo the random generation.
So the human is your source of randomness.
Yeah.
Okay.
Yes. And then I also wanted to touch on like the results. I did like a kind of like critical path analysis of our code. At 30 FPS, we have about 1.3 million cycles available between frame updates to do any calculations we need before we can redraw the TFT. And this is great. This is a lot of cycles. And when I did like an approximate critical path, I found that our code right now at most will use like on the order of like 14,000 cycles. So this is really good because it's really reliable that the frame calculations like to redraw the TFT will occur, and we'll still have plenty of cycles left over to run the button thread and the slider thread. So that's kind of how we're guaranteeing that the game is really interactive and like doesn't lag for the user. And also like having all these spare cycles is good because as we saw in like the Voids lab, if we did something with nested loops, the number of cycles that we're using could quickly blow up. And I think in a game like this, if we wanted to extend it in the future with like more complicated animations or something, it's very possible that we would want nested for loops. So we would like a nice cushion right now if we ever wanted to add more.
Yeah, and for example, like on the explosion, when we get those concentric circles, they actually, the red, like messes up the land, but we have plenty of cycles in between the next turn to just redraw in that little area, the land around the explosion.
Right, okay.
Same thing with tanks moving as well. We redraw the land behind them as they move around.
And then also wanted to talk about the land destruction a little bit. So I'll do a sample fire. So you can see there's so when the projectile hits the land, we select a certain range of X values around that point. What is it? It's like 10. It's like 10, yeah, 10 each direction. And within those 10 X positions, we just check the land height value in the array, and then we decrement it by, we decrement all of them by the same amount for a certain projectile. But as you can see here, yeah, here, let me, that's a good way to go down. So you can see if we have very low power, there's not much land destruction. And then if we have very high power, there's a lot of destruction.
Oh, wow, that's
yeah,
cool.
so we did initially want to add different weapons, and maybe if we had more time, that's something we would do, but we thought this was a really good like first step for that, where you selecting your weapon is just scaling your power and scaling the amount of destruction you can do.
Yeah, and the way it destroys will always like just decrement it down. So if you're shooting at a mountain that another tank is on, then the tank just moves down with the land like it's crumbling below them because you're like shooting them off the mountain.
We kind of vanish atoms from existence with our explosions.
Gotcha.
That's all we had for now.
Yeah.
If there's any questions or anything else you wanted us to see?
Well, it's very carefully worked out. You have to, you've gotten a lot of all of the edge cases that I've seen working.
Yeah, some random edge cases we had was when we were having a lot of trouble because the TFT is 0 indexed up in the top. So just thinking about these Y values was always opposite. So one of our issues was when you were going super high power up there, it was actually redrawing. It was cutting out land below because it was looping all the way around with the negative values. And we just had to do some checks and print some values to the screen to see what the actual Y position it was when it was going where it wasn't supposed to be and it was negative. So we just added a bunch of flags in there to make sure that it wasn't redrawn.
Yeah, so we allow projectiles to go off the screen and come back on the top as well. I don't know if you showed that already.
Yeah.
But to the side, they immediately like, we're done, next turn happens. We don't kind of wait for that to land somewhere in the middle of nowhere off this TFT on the left or right.
Right.
Might hit himself. You can't self-damage in this game. We do have self-damage.
Okay.
Yeah, if you shoot up, you might hit yourself. And yeah, we seemed everything we tested, almost all the edge cases we have in terms of like odd destruction cases and
Yeah, and
land everywhere.
You can't drive off the left or right side of the screen. And also the two tanks will come together and meet, but you can't pass each other. Like your side is your side.
Okay.
You don't have contact damage installed in the game as a feature.
Really well thought out. It's a really good implementation of like a very familiar game. I remember playing games like this.
Mm-hmm.
Yeah. Really nice. Demo's really nice.
I like the feedback to Python also.
Yeah.
It's so readable to have it all on the control panel there.
One other bug I want to touch on, this one was pretty tricky. The way we move the cannon is that, as expected, like you redraw or you erase the cannon in black and then you redraw it in white. And something that was causing, and this is a perfect scenario, is that you would erase the land if the cannon moved inside the land, because you would be redrawing black where the cannon was. So we were able to like completely erase the land. And this was pretty hard to figure out how to get looking nice. But what we've decided to do is that as you move the cannon, you check the midpoint of the cannon. And if the midpoint is above the land, you draw it in black. And if the midpoint of the cannon is below the land, you redraw it in blue. And this isn't perfect, but as you can see, it's not very noticeable. Oops.
Right.
It's not very noticeable. And as soon as you move over the land, because it's just stored, we just keep redrawing it. So we're pretty happy with like how that turned out. And it's not perfect, but
Yeah,
it's
it's a
something
nice
that you
solution.
wouldn't really notice it unless it was like pointed out. So but that was a
Nice.
tricky bug.
Very nice.
Very nice indeed. And it seemed like you had a good deal of fun actually developing this.
Yes, it was very
Yeah.
fun.
Yeah, I think at the beginning we kind of were like being able to just like draw the land and have tanks. We're like, oh my god, this like happened. This materialized quicker than we thought. We thought like individual pixel drawing in this would be just a total headache. And then once we had like an elevated portion land, like, oh my god, like part of the land is not flat, or like the tank could go on a little triangle. That was amazingly impressive to us.
Yeah, I think once we decided to do a triangle and a rectangle, we were like, wow, this actually looks like tanks.
Yeah.
I remember too, I think it was like the first week you started working on this, you started by just sketching things out on like a notebook. And by the end of that lab period, you had something on the TFT display that looked exactly.
We have some
like
initial
your
concept art. We could bring it up actually. Let's see.
the extent to which you built what you did, what you had designed was very impressive. It looked exactly like what you had imagined.
Yeah. Yes, we had a work in progress document of everything we did
Our
each,
thoughts.
our goals each time, and this is what it
This
looks
is our
like.
first
Yep.
stable release. It
This
was,
is exactly the first day. This is what we got. And then like here's like we have check marks of what we did each day. And
Oh,
This
there
is
it
our
is.
concept art.
Yeah, that's the picture I remember. Yeah.
I drew this and I was like, guys, trust me, this is what it's gonna look like.
Yeah, unexpectedly accurate picture.
Yeah.
Very nice.
Excellent. Excellent.